What you're looking at is a brand new planet we didn't know was out there until now.
NASA has announced the discovery of the most Earth-like planet ever.
The James Webb Space Telescope has made a discovery that will forever redefine humanity's place in the cosmos. After years of relentless observations and analysis, scientists have confirmed that JWST has detected unmistakable signs of life on Proxima B, the rocky exoplanet orbiting the red dwarf star Proxima Centauri. This isn't just another promising lead or a collection of ambiguous signals. It is the definitive evidence researchers have been hoping for since the search for extraterrestrial life began. The revelation has come not in whispers of speculation, but in a thunderclap of data. Spectral readings so precise and intricate that they remove reasonable doubt. Proxima B, just over 4 light-years away, is no longer just Earth's closest potentially habitable neighbor. It is now a confirmed cradle of life beyond our own world. Before we start, smash the like and subscribe buttons for more updates. JWST's discovery stems from its unparalleled sensitivity to infrared light and its ability to peer through cosmic dust with unprecedented clarity. Using its near-infrared spectrograph NIRSpec and mid-infrared instrument MIRI, the telescope analyzed the chemical composition of Proxima B's atmosphere as starlight passed through it during transits. What it found stunned researchers. The planet's atmosphere is teeming with biosignature gases, most notably a highly unusual concentration of oxygen, methane, and carbon dioxide in a chemical disequilibrium that, by all known natural processes, should not exist without biological intervention. Even more remarkable was the detection of isoprene-like compounds and dimethyl sulfide, gases on Earth that are predominantly produced by marine plankton and microbial life. The spectral patterns were sharp, clean, and repeatedly confirmed over numerous observations. There was no mistaking it. These weren't signs of volcanoes or random chemical reactions. They were signs of life. Proxima B has long intrigued astronomers. Discovered in 2016, it lies within the habitable zone of its star, receiving just enough energy to potentially support liquid water. Its mass is slightly greater than Earth's, and early estimates suggested a rocky surface. But given its proximity to a flare-prone red dwarf, doubts lingered about whether its atmosphere could survive the star's violent outbursts. Those doubts have now been erased. Not only has Proxima B retained a stable atmosphere, but that atmosphere is dynamic, rich, and biologically active. JWST's data even hints at seasonal variations, subtle fluctuations in gas concentrations that could correlate with biological cycles. It paints the picture of a living planet, not a dead rock. This discovery shatters the illusion that Earth is somehow uniquely privileged in hosting life. It confirms that biology is not an isolated quirk of one pale blue dot, but rather a cosmic phenomenon waiting to emerge under the right conditions. The implications ripple out in every direction. If life can arise on a world around a red dwarf, a type of star that constitutes nearly 75% of all stars in the Milky Way, then life might be far more common than previously imagined. Red dwarfs were often discounted due to their activity and the tidal locking of close-orbiting planets, but Proxima B defies those assumptions. Its biosphere has either adapted to or thrived in these conditions, suggesting that the universe might be teeming with microbial or even complex life in places we once dismissed. The nature of life on Proxima B is still largely unknown, but JWST's instruments have painted a faint but thrilling sketch. The atmospheric data suggest metabolic processes similar to photosynthesis, though likely adapted to the planet's dim reddish light. The presence of gases like methane and oxygen together, which on Earth would rapidly react and neutralize without constant replenishment, points to a living source. It evokes a scenario of alien ecosystems, perhaps microbial mats spreading across the surface, or bioluminescent organisms dwelling in dark oceans. There is even tentative evidence for cloud patterns and possible surface water, though these require further validation. What is certain is that the chemical symphony of the planet's atmosphere does not align with sterile geology. Technologically, this breakthrough is a triumph for JWST. Its capabilities have exceeded even the most optimistic projections. In essence, it has become the first instrument to directly detect life beyond Earth, fulfilling one of humanity's oldest dreams. Its ability to isolate faint molecular fingerprints across interstellar distances is akin to reading the scent of a flower on a planet orbiting a distant star. The years of painstaking calibration, the precision engineering, the collaborative efforts of thousands of scientists and engineers, all of it has culminated in this one moment of profound insight. JWS has not only gazed into the void, but returned with a message. We are not alone. The timing of this discovery is poignant. As Earth grapples with climate change, resource scarcity, and geopolitical strife, the confirmation of life on another world feels like a reawakening. It offers a new perspective on our responsibilities as stewards of our own biosphere. It challenges the anthropocentric view that intelligence and life must always look or function like us. The organisms on Proxima B, whatever their structure or complexity, exist outside every myth, every religion, and every history we've written. They are a second Genesis, born of alien conditions, evolved along an entirely different tree of life. Philosophically, the discovery forces a re-examination of our place in the universe. It ignites old questions with new urgency. If life exists there, how many other worlds are alive? Could some host intelligent beings watching us as we watch them? Are civilizations separated not by distance but by time, rising and falling across the ages, unaware of each other's brief flickers? Life on Proxima B is the first confirmation that the spark exists beyond Earth. Whether it is a microbial murmur or the echo of something greater, it is a beginning. A cosmic opening chapter. The search for life has always been intertwined with the search for meaning. From ancient astronomers gazing at the stars to the construction of JWS, the question has remained constant. Are we alone? That question now has a partial answer. Life has emerged at least twice. Once on Earth and once on a distant world orbiting a dim red sun. And if it has happened twice in such a short span of cosmic real estate, then the odds are high that it has happened countless times. The confirmation on Proxima B is also a wake-up call for the scientific community. It signals that the tools to find life are now in our hands. No longer must we rely on speculation or theoretical models. We have observational proof. This will galvanize funding, research, and international cooperation as missions to further study Proxima B and other exoplanets are fast-tracked. The roadmap of space exploration has shifted. Priorities will tilt toward biosignature hunting, planetary atmospheric studies, and the search for habitable moons and water-rich environments. There's also a renewed focus on the question of contact. If microbial life exists on Proxima B, could it evolve into something more complex? Has it already? While JWST's instruments cannot directly image the surface or resolve macroscopic life forms, future technologies might. The next generation of telescopes and interstellar probes will now aim not just to visit other worlds, but to explore their ecologies. The dream of discovering an alien ocean, a forest beneath a dim sky, or bioluminescent creatures drifting in crimson clouds has shifted from science fiction to scientific ambition. The presence of life on Proxima B also opens the door to entirely new branches of biology. Xenobiology, once a speculative niche, now becomes a legitimate empirical science. Researchers will study how alien metabolisms function, how cellular structures could differ in gravity and radiation environments unlike Earth's, and what evolutionary pressures shape organisms under a red dwarf's light. Every new discovery will test the boundaries of what we understand about the nature of life itself. It may even lead to revolutions in medicine, energy production, or biomimetic technologies inspired by alien adaptations. For astrobiologists, this is the discovery of a lifetime. Every element of their discipline, from extremophile research to atmospheric modeling, has led to this moment. Years of scrutinizing Martian soil samples, analyzing Europa's icy crust, and simulating exoplanet climates have now borne fruit. The hunt was never in vain. It was always leading toward the eventual confirmation that life isn't an earthbound anomaly. This revelation has also reinvigorated interest in the Proxima Centauri system. Proxima B is just one planet. Could there be others? JWST has opened the curtain on one world, but what lies beyond? The red dwarf may harbor additional rocky bodies or moons that could also support life. The entire system is now under intense observation as astronomers scour for further signals. The door is open. The silence is broken. Humanity stands at the threshold of a new era. For millennia, Earth has been the only known vessel of life. That monopoly has ended. Proxima B, once just a point of interest, is now a symbol of potential, of possibility. It challenges the isolationist thinking that has dominated scientific and philosophical worldviews. Life is not a miracle confined to Earth's cradle. It is a force of nature, as fundamental as gravity, as expansive as the stars themselves. In practical terms, the discovery accelerates discussions about interstellar travel. While 4 light-years is an immense gulf with current propulsion technology, the confirmation of life provides compelling motivation to bridge that distance. Concepts like laser sail probes, nuclear fusion drives, and generational starships now carry the weight of purpose. This is no longer about the abstract dream of exploration. It is about reaching a living world. A world with its own biochemistry, its own ecosystems, perhaps even its own evolutionary stories. The human instinct to reach out, to explore, has never been more justified. All of this, from the molecular whisper of methane to the sweeping implications for civilization, has been made possible by the James Webb Space Telescope. It is the sentinel that pierced the veil. In its mirror, we did not just see a reflection of the past, we saw a future rich with life, complexity, and unknown potential. The telescope's mission was to look further than ever before. Instead, it brought the cosmos closer. It brought life home. This discovery is not an ending, but a beginning. It is the spark that will ignite 1,000 new questions and 1,000,000 new dreams. It validates decades of effort and dares the world to imagine more. What lies beneath Proxima B's clouds? How does its biosphere function? Could there be intelligence waiting, watching, evolving? The answers may be years or centuries away, but the first step, the first undeniable confirmation, has been taken, and it came from a golden eye drifting in the dark, silently capturing the story of another world. The journey from speculation to confirmation has redefined not only astronomy, but our very sense of existence. The stars are no longer mute. At least one of them whispers a secret. Life is not unique to Earth. It is not fragile, not improbable. It is out there, and we have found it. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on life on Proxima B? Will JWST confirm it? We want to hear from you. Thank you for watching and see you next time.